scientific method generating knowledge over a long period of time, but really in science class, we're concerned with designing really good single-time experiments. So this is the process of experimental design. And you should be pretty familiar with this as like the traditional scientific method that you probably learned in middle school. The first thing to do is ask a question or state a problem. The second thing is you do some background research, find out what there is about your question or problem. You write a hypothesis, would be the next step. Step 4, test your variables or go out and do your experiment. Number 5 is collect data and take measurements. Number 6 is analyze data and figure out what does the data mean. 7, you would write a conclusion that either proves or disproves your original hypothesis, and then communicate your results, share with other scientists what you found out, and go back to step 1, asking more questions and trying to figure out new solutions to problems. All right, I keep saying how it's really important to share your results as a scientist. And graphs are the way that scientists share the results a lot of the time because it's a very good visual model to understand what's going on. Being able to create a good graph is an essential science skill. So we're going to go through a situation and look at the graph and identify some really important pieces that your graph must have in order to be a good graph. Here's the situation. You are a scuba diver. Picture yourself outside near an ocean. And one day, you want to dive down into the ocean deep. You're recording the pressure in atmospheres using an instrument called a barometer. That's an interesting science word because baro means pressure and meter means to measure something. So a barometer is literally a tool that measures the pressure. You're measuring this pressure at different ocean depths measured in meters. Meters is one of the metric units we're going to talk about a lot. So the following graph is a visual representation of the relationship between these two variables. As you dive down deeper, what's going to happen to the pressure? Here's the graph. So if you started at a depth of 0 meters, you have 1 pressure of atmosphere. And as you can see, this pressure is increasing as the depth is also increasing. TAILS is a great acronym to make sure that you have all of the important pieces of graph that communicates a good scientific relationship. So the T in TAILS up here, TAILS, stands for title. All good graphs must have a title. The title for this graph, dive depth and pressure. Axis. All good graphs must include an x-axis and a y-axis. That's the A in TAILS. The next part that all good graphs include is intervals. You should pick appropriate intervals to fit your graph. So on this side, as you can see, the depth is going up by 5 meters each time. And the interval on the y-axis is going up by 0.5 atmospheres each time. We picked these as appropriate intervals for this graph because it fits our data really nicely. The other thing that all good graphs include is labels. Labels is the L in TAILS. Here we've labeled our x-axis depth in meters with the abbreviation, and we've labeled our y-axis pressure in atmospheres, or ATM. The other part of a graph are scales. The scales need to be appropriate just like the intervals, but they need to make sure that you include your whole data set. So on our x-axis, our scales go up to 45 here, so it fits all of our data, maybe with just one little extra point where we might be able to make a prediction. And our y-axis have scales from 0 to 5.5 in order to fit our data. So I like to remember TAILS when I'm doing a graph to make sure I have all the important pieces of a graph in order to communicate my results. T, title, A, axis, I, intervals, L, labels, and S for scales. So the other important piece of a graph that I'd want you to be able to interpret is the relationship between the variables. We kind of talked about this already, but on your x-axis is always going to be your independent variable. In this scenario, that's depth in meters. On your y-axis is always going to be your dependent variable. In this case, that's pressure in atmospheres. Independent x, dependent y. So if we're talking about the relationship between these two variables, we'd want to start with the independent variable. That's what we controlled or manipulated when we did this experiment. We controlled how far down or how deep we dove into the ocean. So here we go. As the depth in meters increases, that's our independent variable, we're asking what is happening to the dependent variable? Well, as the depth in meters increases, what do you think? If you said the pressure increases, you'd be right. The pressure in atmospheres also increases. So as the depth in meters increases along our x-axis, getting bigger, our pressure in atmospheres also increases, getting bigger. Awesome. I think that's all I have for these slides. The next thing that you need to watch after seeing this video is the Edpuzzle, Nature of Science, the Amoeba Sisters. They address some things that I didn't get to in my slides that you still need to know. All right, so then after that, I gotta go back and look what we got. So after you watch these two videos, you have some readings to do. So the Google Doc that I made for you this week is right here. It's the scientific method vocabulary list. Feel free to, on your own copy of this, make your own notes or highlight important words. It covers all of the vocabulary that I expect you to know for this unit. It also gives you tails one more time down here for good graphs. Please come to Zoom hours if you have questions on what any of these words mean. All right. And the other thing I want you to do is read this section in your textbook. The first section I want you to read is section 1.4 on measurement and graphing. Wanted to point out that you can either find this section by looking in the chapter. So if you go to chapter 1 over here and you go to section 1.4, here's the section I want you to read. Or if you wanted to find the page number, like for the next section is section 2.2. Starts on page 40. I could just type in page 40 up here and it'll get me to the page that I want you to read. So read section 1.4 and also section 2.2. It's like 3 or 4 pages of sections, not a lot. All right, good information in those. Okay, and then once you're done reading those, I'd like you to take this experimental design scenario and go through the scientific method yourself. So here's the scenario. It says, for his science fair project, Alan planted 10 seeds in each of 5 pots that were found around the house. Each contains 300 grams, G is abbreviation for grams, of potting soil. He added the following amounts of water to each pot every other day for 40 days. 50 milliliters, 100 milliliters, 150 milliliters, 200 milliliters, and 250 milliliters. Pot letter C received the amount of water recommended by his gardening manual. At the end of 40 days, Alan measured the height of each plant. So pretend like you're helping Alan with his science fair project and go through and create a title, a hypothesis, identify independent and dependent variables, the number of trials that Alan did in the experiment, constant variables, control group, the type of data or what measurements were Alan taking, and then 2 possible improvements to help Alan improve his experimental design. Okay, So this is like your activity for the week where you're applying your knowledge from what you found out in the reading and the videos, and you're coming up with your own experimental design with it to fit this scenario. The very last thing I want you to do this week is to get on Gizmos and practice some graphing. You'll have a class code in the directions for the Google Classroom assignment. I'm going to use the class code for period 1, physical science energy. So that's RXJDBB. You enter it into the student class enrollment here, and you need to be on explorelearning.com. I'll put that in the directions too. So when I hit enroll, it's going to ask me if I already have an Explore Learning account or if I need to create an Explore Learning account. Go ahead and say create. Okay, so then you would go through and fill out your personal info. Make sure you use your 4J email address here. I'll go ahead and fill it out like if I was doing it. Christina. Trujillo. Okay, 4J email. And then you're going to create your own username and password. So I'm going to make my username the same thing as my 4J, just because I don't want to have to remember a lot of things. And then maybe you use your same password as well, or you could come up with your own password. Just make sure that you write this down someplace, remember it, because we're going to be on Gizmos again and again. If you lose your username and password, I can always look it up for you, but it would be really great if you could write this down someplace so you could remember it. Okay, so I'm going to use my password here. And then hit submit. It'll take you to this. The Gizmos that I want you to do is graphing skills. So you're going to click on graphing skills. And never remember my thing. And here's the Gizmos that I want you to do. Now, this doesn't come with any directions. So you also need to have open at the same time as the Gizmos this worksheet. Okay, this is where you're getting your directions for what to do. So let's look at this. The first thing it has here are some vocabulary words that you need to know in order to do the Gizmos. Those would be important to know. Oops. All right, cool. And then it wants you to answer some questions even before you start the Gizmos. So here's 4 kinds of graphs: a bar graph, a line graph, a pie chart, and a scatter plot. I want you to circle the kinds you have seen before. So go ahead with the circle tool and circle the ones that you have seen. All right, cool. In order to make it transparent, just fill the shape in with something transparent. Fill. All right, circle the ones you've seen. Then it says, where have you seen these graphs used? Maybe you've seen them in science or math class. So you would type in, I have seen this before in math class, or I saw a pie chart today in the newspaper. Okay, why do you think these graphs are useful? Type your answer there. Now it's going to give you directions on what it wants you to do in the Gizmos. So it says the graphing skill Gizmos starts with a bar graph on the right and a data set on the left. Practice using the Gizmos by doing the following. I want you to write a title, give the graph some axes, and change the scale of the vertical axis by dragging the bars up and down. I go back to the Gizmos, and we want to make this a title that makes sense to fit our data. So for this bar graph, looks like we're talking about animals and their speeds. So I'm going to say the speed of different animals, for example. You can choose whatever title you want as long as it makes sense with the data. Okay. And then maybe down here we label with animals. And over here, what do you think this should be? Good hint is to always look at your table and see what's labeled here. Speed. In kilometers, km per hour /h. All right, cool. It'll be helpful for you to click these boxes on the show values and the show instructions. That'll help you. Okay. And then I want you to follow the directions on the gizmo and do what it's asking you to do. Okay. Use the graph type drop-down list to select other kinds of graphs. Practice with each type of graph. So then you would go to not just the bar graph, but to the line graph and practice this. Pie chart, practice here, and scatter plot. Okay, so as long as you have this filled out, this worksheet filled out, that's how I'm going to be checking that you engaged with the gizmos. So following the directions on this worksheet is going to be your best way to get full credit. Okay? Awesome. Please come to Zoom office hours if you have any questions doing this. Okay. So after you've engaged with the worksheet and the gizmos and you've done the reading and watched the videos, then you can take our quiz on scientific method and graphing. It is a quiz. It'll probably be about 20 points. I'm going to make it unlimited time just so you don't feel rushed. I know our last quiz was timed question and answer, but this one will be unlimited time. Okay. Good luck with your assignments this week. I'm going to make myself bigger. There we go. Good luck with your assignments this week. Go forth and learn about the scientific method, and thanks for watching this video. Goodbye. Come to Zoom office hours from 1 to 2, Monday through Thursday.